We're going to go over portions of each of the daily work assignments. I have what I call in the geometry book here daily work assignments. That's really the daily homework. And then I have a homework sheet that would look like the chapter test. And so that's really a chapter review is the homework sheet. And then we have a chapter test. So uh, the daily work is just the daily homework. So we're going to go over part of that. There were three undefined terms, remember. The first was point, and then we had one that started with an L, and then you had the third one, right? So point, three undefined terms. You can finish filling in those blanks. We started out with those, and from there we made definitions. Okay? The next little portion is true or false. It wants to know is X, A, and H are X, A, and H collinear points. And for me, I'm not going to let you put a T or an F because people make these little funny looking things, to try to throw the teacher off. So you're going to have to write out the word true or write out the word false if you're my student. But anyway, so points X, A, and H, we would locate those on the graph. There's A, there's H, and there's X. And to be collinear, we would have to be able to draw a line that hits all three. Well, we can't draw a line that hits all three. We can only draw a line that hits two at a time. So the 3 points X, A, and H are not collinear. So it would be a false statement that they are collinear. Okay. The next statement says A, E, and H are collinear. So we'll find them. There's A, there's E, there's H. Are they together in a line? Yes, there's a line that exists that would contain all three. They are collinear, so that is a true statement. Okay. Coplanar are points together in a plane. Let's just look at number 7 since it's an odd one, and you could have looked it up in the back of the book anyway. Don't you just love that? I'm sorry. Anyway, so E, Q, X, M are coplanar. So we'll draw those. I said that one reason because, not just to pick on you, but the odd answers are at the end of the chapter, and they're not only there, but they're explained. So it's like a solution manual to the odd answers at the end of the chapter here in the book. So what we would have to think, is there a plane that exists that would contain those 4 points? Well, if we were to try to draw this thing, then this would connect to here. But to make that connect to there, it would have to twist. Now, a plane is not something that twists, it's something that's flat. So you can see that to connect all 4 of those, we couldn't make a flat surface. It's like we took a piece of paper and bent one edge up. So these are not coplanar. This says they are, so that is a false statement. Any questions on number 7? The real reason we did number 7 is because it bends a little and people might want to call that coplanar, but we're trying to tap into the fact that they have to be exactly in one flat surface, which means that EQ would have had to been parallel to MX for them to be together in a plane. Since those are not parallel lines, then they weren't going to be coplanar points. Okay? All right. The next little series of questions is dealing with intersection. We have the same picture, but if you look at this, it says the intersection of a plane and a line. Now, just looking at how they're named, you can see that they have something in common, And the very definition of intersection is what's common to both. So you can look at the name and know that point X is common to both, but we need to really verify if that's all that is. We should know that unless the line runs through there, then that's it, but we should draw it to check it out. P, Z, X, M then is the plane we're talking about. HX is the line we're talking about. What that line and that plane have in common is that one point, point X. So the intersection of two figures, again, is the set of all points common to both figures. Number 12, we know that we can name a line by a lowercase letter. So we could call this line, line L, or we can name a line with the little arrows and any 2 points on that line in any order that we want to name it. So we could name it line QR, or reverse those, right? The draw and label the following should be done precisely, and in the teacher's edition I have them created precisely. So if you're a student, I would encourage you, if you're stuck, to ask your teacher for questions about how to do it. Some of this draw and label is going to turn into discovery work, and most of the answers to the questions, I guess I should say all of the answers to the questions that it would ask about what is true about this situation as we make discoveries. If you'll turn to the page or two after that, then there will be a theorem or postulate that you've tried to prove. So a part of our draw and label will be to discover the rules that are coming up. Uh, and so again, this is not something that I'm going to go over on every one. It's something that we would hope that the instructor would share with the student. The student would try to be accurate and precise about these, especially when it gets to more specific construction, so that you're really learning how to use a ruler and a protractor, and you're really discovering these rules that we're going to be coming up with. And then not only will you have the words and the logical proof of why this rule exists, but you will have created it on paper so that you could understand in the real world how it would be used. Now, I'm just going to scratch out number 13 a little. It says line L intersects plane M endpoint P. Remember that we would draw a plane by creating a parallelogram, and we would name that plane with a capital letter in one of the corners. And so let me recreate that a little bit. If I was teaching a group of students, then I would want the work to be turned in a little more accurately than just scratched out, kind of sloppy like. But anyway, line L intersects plane M endpoint P. So we would show that a line was coming down through here. We would show where it actually hit the plane from the top, and then where it goes underneath the plane, as you would have stuck a pencil through a piece of paper. And then we're going to show it coming solid out the other side. So that's how we represent that that line was on top. It went underneath as it hit that point. And so we have line L intersecting plane M in the point P. Okay. Number 14 says non-collinear points A, B, and C lie in plane R. So we would begin with a plane R. And somewhere in that plane, we would put these 3 points that do not lie together line. And we'll leave the rest for you there. You're going to start out with planes and do some drawings to show your understanding of that. Okay? All right, so that was the end of Daily Work Unit 1-1, and we'll be prepared later to move into Unit 1-2, as you can see, with more definitions.